Hello everyone. Today we will look at Python binary file reading and writing, or reading and writing files in binary mode. So let us start by simply opening a sim my file, and let us write a sim one character. Okay, just a. So I took my file.txt, and we know that this is a simple write flag. We have seen it previously. Only thing I wrote is a. So now I'm gonna look at the file content and using xdump. I think it's right. I think it's my file. So we see something called 00. These are addresses. So we see 0041. So this thing here, let us say what it is. So inside the computer, whatever we are writing, A, B, C, D, everything happens in the binary mode, zeros and ones, on and off. That's the way computer represents. So corresponding to character, there is some kind of an encoding scheme, and that way things are represented as zeros and ones. So some kind of a coding, so encoding scheme. So all those encoding scheme, for example, is we have lots of, this is a codex on python.org, and we can see there are lots of different schemes used. Something which is default is this UTF-8. Okay, so we'll come to that. So now let us understand the 0041 a little bit. So what is this 0041? Suppose inside this is not binary, this is an hex, right? I use the xdump utility. So 0041. So suppose each of this bit, so this is an hexadecimal number, all right? So suppose this is represented by like 4 bits, like 0s or 1, 4 zeros or 1. So I can represent 1 as 001, right? And 4 I can represent like 0 1 0 0, right? 2 to the power of 2, 4, and this is 0 0 0 0 and 0 0 0 0. So now inside the computer, if it's like a 4-bit per character, so I see something like 0 0 0 0 0 0 0 1 0 0 0 0 1. So that is just for 1a, right? That is the way it is represented. So 40, let us go back and study 41 a little bit more. Okay, what is this 41? So if you want to look at the what is the character corresponding to, or the number, or the binary digit corresponding to a, so we can look at ordinate, or say return the Unicode code point for a 1 character string. So what is that? So if I say I put just a, right, I get 65. If I put say b, I get 66. For example, I can say import, right, string, and I can say for character in ASCII.uppercase, right? And I can say print, for example, for each of A, B, C, D uppercase letters. So everything is represented as a digit. So now this is all in our 10 base, right? Our decimal numbers. If I take 65 and convert it into XE, we got 41, or 41, not 41, 41 in hexadecimal number. So if you, that is the 41 that we are seeing here, right, corresponding to a. So now if I want to go back, I can use the character. So similarly, so I can say character corresponding to 65, right? We got a. So now one more thing, this I can also represent as a string. This is basically 0x41. remember, if I do 0x41, that is hexadecimal, but there's a string. So if I want to represent 60, this guy, as a string, I can also actually pass that into ordinate as well. I don't have to do B or something like, or I don't have to do A. I can say ordinate \x for 1, like that. So that also gives me 665. Okay, corresponding to the we are representing as a X character. All right. So now let us, for example, somebody send you a file and you want to look at the content of the file. Say the file, for example, is called testbin. Okay, and now we know that I can read the file simply by just, I can pass the file name and I can just read. So now we see this error UT of 8 cannot decode certain thing in a certain position in the memory. So what we do about that? So this is technically, right, we know that this is equal to this, right? I just omitted R because R is the default. Is I can just omit if I just want to read it, right? I can pass in a binary mode then B, and then see, I see something like that. So I see something here, right? So now if you want, I can actually look at something here, X, right, F9, something like that. So, and you can say character corresponding to 249. So see, there's some kind of special character there. So that is what is happening. So now when I look at binary mode, it actually showed me the text. So what is Python is trying to convert each of them into, this is called a byte string, and here by, okay, and here Python is converting into the corresponding characters for us, and suddenly it encounters something it can't, and it dumps this. The byte string is simple. Similarly, we can, for example, it can concatenate to byte string and use it. And now for example, I can write in a similar fashion. For example, I can write open my first bin file or something. I just put txt as the extension, so I can say write binary, and I can write, right? So when I write binary mode, the Python is expecting a binary, a byte string, okay, and I can open that in read binary format, and I can read it, right? So here you can see that this doesn't contain any special character or anything like that. So I can actually also free to open that in just a simple text mode. So now let us go back and study this, or look at this guy again a little bit more. So when I read this guy, right, I get that thing, and if you want, you can open that file in one of the text editor and look at how it looks like. So now if I take that thing, I can see, I can ask it to maybe decode for me. Okay, I can ask it to decode. So we have lots of cortex here, and you can ask the person who sent the file, or or it can maybe, depending upon the language that you expect, maybe there's a Vietnamese character or Chinese character. For example, let us try this Western European thing. So Latin 1, correct? So I say encoding equal to Latin _1. So now this byte string has been converted into this. So you see, we see those characters, okay? So this is where we can encode. So now there's one more thing we can do. If I import sys module and look at sys.get, so you see the default encoding is UT of 8. So that is why we were getting an error when if you just read in the text mode, you are getting an error, right? Suppose if I do this, getting an error. So now I can actually pass encoding here in a text mode file and say Latin _1. So now see, I can get that. So and now, for example, let us take this guy, right? And let us rewrite. Maybe I can say encoding, maybe UTF-16. I encode C, I get this thing, and let us write it to a new file. For example, open my bin file, right? And I have to write binary, or I can write binary, and I am going to say write, and then I'm going to take this guy, for example. So I took a binary file, I opened it in a binary mode, and I'm writing that I encoded using UTF-16. So I wrote this. Now let us go back and open this guy. I'm going to read the binary, right? And if I say read, I get this. Or we can say, remember, I can say I know now the encoding because I only did. So it's UTF-16, right? I can read it. Or if I suppose I to again the same problem, right? If I do something like that, I get something completely messed up thing. So this is the point. So you need to know the encoding when you are reading the file in text mode, and pass it the right one so that you can read the file in the right way. So this is what we these are some of the ideas from Python binary file reading and writing. So we can pass in simply a binary mode. We know how to find the VNC, ORD, ordinate finding, and the CHR function, the character function, and we know we looked at the encoding schemes and all. So thank you very much for watching.